Okay, for 16, I'm looking at it, and I noticed that the answers are listing. I got all finite numbers, and one of them is none of the above. But looking at it, I'm going to say, for comparison purposes, it looks like it converges. It just say it compares nicely to a p-series. But the deal about this one over here is that I think it has something to do with partial fractions. So what I want to do is I want to do a partial fraction decomposition. So I'm going to say this is going to be n plus 4, and then n plus 1. Right, I'm looking at the AN in this case. And I'm going to say, I don't know yet, but I'm going to say it looks like A over, I'm going to put n plus 1 first, and then plus B over n plus 4. I'm going to multiply both sides by the LCD. You get 1, then you get A, n plus 4. Then you get B, and you get an n plus 1. All right? So what I'm going to do now is pick an easy number. I'm going to pick n to be minus 1. And what do you get there? You would get 1 on the left side, and then you get 3a. So I'm pretty comfortable that a is 1/3. And then I'm going to pick n equals minus 4. And what do you get there? You get 1. And let's say you get minus 3b, right? And what is b going to be? b is minus 1/3. All right, what I'm going to do is I'm going to rewrite it as, this is 1 over n plus 4, n plus 1. This is the sum, n equals 1. I'm going to do what's called the partial sum. You can go to n, and I'll write this down for you. N equals 1, up to big N. N is some finite number bigger than 1. And what do I get over here? Well, I do see the 1/3. I'm going to pull that out. And then what do you get? You're going to get a fraction. And the a, if I pulled the 1/3 out, would be 1 over n plus 1. And then I get minus, and again, I pull the third out, 1 over n plus 4. All right? Now what I'm going to do is I'm hoping it's telescoping, and I see the pattern. It's 1/3 times. I like to chase one rabbit at a time. So I'm going to write down the first term. So it's going to be 1 over 2, and then, plus 1 over 3, plus 1 over 4. And I'm going to do yada, yada, yada. I'm going to go down over here, by the way. I'm going to write these over here. I know it's writing over my work, by the way. But I want to get to that last term. And that last term would be 1 over big N plus 1. Let me write the next term down. What's that going to be? 1 over, let's see, it would be 1. 1 plus 4 is 5. And then minus 1 over 6. Then minus 1 over 7. Yada, yada, yada. And let me go to the last term now. What's going to be big N plus 4. Let's start going backwards. It's 1 over n minus 1 over n plus 3. Going backwards. 1 over n minus 1 minus 1 over n plus 2. And I'm starting to realize I'm really not seeing a collapse yet, so I need to add additional terms. So I'm going to say 1/5 minus 1/8. Let me go backwards here. This could be 1 over n minus 2, and this will be minus 1 over n plus 1. I want to go through the cancellations for you, though. As I do that, I'm going to point out, I'm seeing it collapse this way. Then I would see this collapsing over here, this one collapsing over there, that one collapsing over there. And if I went backwards, what would I get? Well, I'm seeing the collapse over here. So what would I see over there? In Sn, and this is Sn, by the way, Sn equals, well, let's write this down. I'm going to write down the first 3 terms, which is 1/2, plus 1/3, plus 1/4. And then I have 3 terms in the end. It's going to be minus 1 over n plus 2, minus 1 over n plus 3, minus 1 over n plus 4. I want to show you where this is written in your notes, by the way. And this is written over here. By the way, I forgot I just noticed that I forgot to put the 1/3 down. This is written over here. All right, 1/3. I see the 1/2, 1/3, 1/4. Then I see minus 1 over 2, and 3, blah, blah, blah. I see it, all right? What do you do now? You take a limit as the big N goes to infinity. And this would be the infinite sum, by the way. What are you going to get? 1/3, 1/2, 1/3, 1/4, and those last 3 terms would disappear, by the way, and gets really large. Now, granted, I got troubles now. I got to do the arithmetic. Now, mistakes can happen, and I want to point out multiple choice exams, typically if you make a stupid mistake, your answer will not be listed. But if you're making what I call a common mistake that other people would make that don't understand the material, that answer would most likely be listed. All right, so let me go through this, and I'll write down what I see. I see 1/3. I'll get a common denominator. That's going to be 12. And then what do you get? Well, let's see, 6 plus 4 plus 3. Let's see, 6 and 4 is 10, 13. And 3 times 12 is 36. I'm hoping to see 13 over 36, by the way. And I see it right over here. I see 13 over 36. All right, let me just talk about the notes a little bit. I do list answers in the notes, by the way. Like I said, the solution is A. By the way, don't believe that if I were to give this to a student that the answers would always be A. What I would do, I would jumble these up over here. These would get jumbled, all right? Now, granted, I put work down here for a reason because this is my work, right? This is what I would put down for the problem, right? If I were actually taking a written exam. But on an exam like this, if it's multiple choice, you can be as sloppy as you like, by the way. What's your goal? To get this over here. How do we do that? Partial fractions, a partial sum, and then a limit is n1 to infinity. Thank you.